Okay, this is a section 3.4, que is the library of the function and piecewise defined function. Okay, graph the function listed in the library of the function. The first function we are studying is a constant function. This is the equation. F of x is equal to any number, any real number. This is the graph. Now domain and range is, domain is all real number, of course, and the range, no, range is only the value of the b. Okay. How you graph it? Using the graphic calculator. Using the graphic calculator, you press y equal, you put, for example, 5, or the number is a constant, and press graph, and you see the horizontal line. Okay, the first function is the constant function. The constant function is y equal any number. I suppose to here is a horizontal line. Horizontal line. Now the domain is all real number. The range is only 2. In this case, y is equal to 2, so the value of the y. This is a constant, no increasing, no decreasing. Obviously, it's even function because it's symmetric with respect to the y-axis, and the only intercept we have is y-intercept is 0,2, and x-intercept have no, because never cross the x-axis. It's a constant function. No increasing, no decreasing. Okay, the second function is identity function. Identity function is a linear function. Special linear, the equation is x, f of x equal x, and the graph looks like a straight line passing through the origin and a slope one. In this case, domain and range both are all real numbers. And the graph using the calculator is you press y equal key, you put x, press graph, and you see the graph of the identity function. Okay, now identity function. The formula is y equal x. In this case, domain and range both are all real number. The function is always increasing. It's typical of function, and the only y and x intersect is the origin, 0,0. And 3 typical points, 0, 0, 1, 1, and -1, -1. And it's obvious that this function always is increasing. It's typical odd function because it's symmetric with respect to the origin. Okay, the next function is a square function. Square function is the function f of x is equal to x to the second power. The graph looks like that. This is a parabola. Okay, this is a typical point, and the domain is all real number. However, the range, no. The range is only the positive value. From 0, including 0 to infinity. Now, using the calculator, you press y equal, you put x to the second power, press graph, and you see the graph of the... Okay, this is a square root function. And the equation is y equal x to the second power. The domain is all real number. The range, of course, no. It's only positive value. You see the parabola cover the positive y value. The behavior is different. For example, when the negative part is decreasing, look, from left to right, walking from left to right. This is decreasing in negative part and increasing in the positive part. It's typical even function. Y and x intercept is the origin, 0, 0, and the some typical point is 0, 0, 1,1, negative 1,1, 2,4, and negative 2,4. The next is cubic function. Cubic function, the equation is f of x equal x to the cubic power. The graph will look like that. It's typical odd function, and domain and range both are all real numbers. The calculator. You put x to the cubic power and press graph, and this is the graph. Okay, the graph of the cubic function is look like that. Domain and range of both are all real number. The function always increasing. Remember, we're walking from left to right to see if it's increasing or not. Look in this direction. The increasing function. A typical odd function. The only intercept we have is 0,0, x and y intercept. And the typical point are 0,0, 1,1, negative 1, negative 1, 0,0, negative 1,1, positive 1,1, and 2,8, and negative 2, negative 8. This is a square root function. This is the equation, f of x equals square root x. The graph is like that. And the domain and range both are all real number. All real number, no, sorry. Positive number from 0 to infinity, including 0. And calculator, you put the square root. The square root we have directly here in the keyboard. The graph looks like that. Okay, this is a square root function. Domain and range both are positive number. The function always is increasing in the whole domain. It's neither, and the y and x intercept is only 0,0. Typical point is 0,0, 1,1, 4,2, 8,3. Okay, cubic root function. Cubic root function is this is the equation. This is the graph. And domain and range both are all real number. In the graphic calculator, we put cubic root. When you're using this, you press Mathematica, and the option 4 you can find cubic root. Now press graph, and you see the cubic root. Okay, this is cubic root function. Domain and range both are all real number. It's increasing always. It's typical odd function. The y and x intercept is 0,0, and the typical point are negative 1, negative 1, 0,0, and positive 1, 1. Okay, this is the reciprocal function. This is its equation, 1 over x, and the graph look like that. Domain and range both are all real number except 0, because 1 over 0 is undefined. And using the calculator, you put in the calculator, press y equal key, press 1 over x, press graph, and the graph looks like that. Perfect. Okay, this is the reciprocal function. And you see clear, this is the equation, 1 over x. The domain is all real number except 0, and the range is the same. Always is decreasing function, decreasing whole domain. It's typical odd function and have no x and y intercept. Typical point is 1,1 and negative 1, negative 1. Okay, absolute value function is the next function. The equation is equal bar, absolute value of x inside bar. The graph will look like approximately that. It's typical even function. Domain is all real number. However, the range no. The range is only positive value because we have no negative bar. absolute value always produce positive. Now goes calculator. On the calculator language, absolute value is ABS. ABS of x, press graph, and you see the graph of the piecewise function. Okay, this is a graph of the absolute value function. Domain is already a number. The range is only positive. It's decreasing in the first part, but it's increasing in the second part. It's typical even function. The only intercept is 0,0, and the typical point are 0,0, 1,1, and -1, +1. Okay, the last function is a graded integer function. This is one way to represent the symbolic way of this function, int. The graph is weird, very weird. Look like that. I would like to explain in detail after in the board. And the domain is all real number. However, the range no. The range is all integer number because the answer is always integer number. Okay, now let's see the calculator. The calculator, you put int of x and press graph. You put discontinuous style, and you see something like that. Look like one is there. Okay, this function is a little bit weird, but the most important is not the characteristics. It's even, it's odd, it's discontinuous. And the way to indicate when it's discontinuous is we're using the circle empty and the circle full. The circle empty indicate is no defined the value here, and the circle full indicate yes, it's defined. And we're using this in the next section because piecewise function. Now the next topic is a piecewise defined function. I see one couple of the examples of this. Okay, piecewise function. Let's do in the graph of this piecewise function. This piecewise function contains 3 pieces. The first piece is x plus 3. It's valid for the if x is less than -2. The expression x is valid between -2 and +2, including both endpoints. And the last is valid in x greater than 2. So let's do it one by one. The graph. This is the first line, second line, third line. Okay, this is x plus 3, x, and minus x plus 2. Okay, now the transition point. The transition is this point and this point. Before -2, we travel for this line. And between -2 and +2, we travel for this line. And after 2, we travel for this line. Okay, now the piecewise function look like that. Okay, before -2, we travel for this, and between -2 and 2, we travel for this, and after +2, we travel for this. Okay, and what about the transition point? Transition point, for example, this point is NT, because the reason is because in the piecewise function we have no equal here. So we have no equal, we have equal here and here, then it's obvious that this is full, and this is empty. The rest of the graph, and even the transition point is eliminated. Now, actually, the graph of the piecewise function is this graph. This is the strategy for doing the graph of the piecewise function. Okay, another piecewise function. This is the piecewise function. Okay, we want to study the 3 pieces again. The first piece is linear function if x is less than 1. The second is x squared, que es a parábola, or square function if x is in between -1 and 2, and 6, que is a constant function if x is greater than 2. Okay, let's do it piece by piece. first piece is the line. Second piece is the parabola. Third piece is the constant function, is the horizontal line. Okay, now transition. Transition in this case is -1 and +2. Now our piecewise function looks like that. Okay. Now the transition point. The first point is ending. -1, -1. The second is full. -1, +1. The third one is full because it's equal equals full. And the last one is empty, I suppose, no? It's empty, yes. Okay, now let's see the actual piecewise function. Let me remove the auxiliary curve, because this, and this. And why not the transition point? This and this. And actually, this is the piecewise function, the graph of the piecewise function.